Hello, welcome to the Physionic Podcast. My name is Nicholas Verhoeven. I'm a PhD student in molecular medicine, and I have my master's in exercise physiology, and I've been in the science world for, well, a small while, but it's been a number of years. If you're new to the channel, welcome. This is a channel and a website dedicated to learning the human body in essentially any aspect related to physiology and nutrition. And what you can look forward to is a science-based education that is, of course, transparent, meaning that if you find critiques and things that you think are incorrect, I'm more than open to correcting my point of view on something, because I think that is ultimately the idea. That's really what science is, to be able to be correctable, to correct continuously until you get nearer and nearer to the truth and hopefully eventually find that truth. But anybody who has been following the channel for some time, the podcast for some time, the website, the Instagram, and all the number of different other mediums, then welcome back. Thanks for tuning in as always. Okay, so today, as usual, I've got a number of different topics. There will be timestamps for you, and we're going to be focused a lot on cardiovascular disease this podcast, but some interesting prospective studies, as well as, I believe, a retrospective study looking back at research and a series of different studies looking at heart disease and cardiovascular disease in general. So relating things like genetics, sleep, and cholesterol, how those impact heart disease based on new evidence. And the final topic is going to be talking about sugar consumption. It was kind of a weird, interesting study that came out looking at sugar consumption, really high sugar consumption, and its impact on male fertility. So stick around for that. Okay, so the first topic is looking at genetics and sleep, and this is an associative study. So, well, let me give you a bit of background on genetics, not to go too in depth with it. You're likely aware that our body is, all of our cells have genes in them. They have DNA. They have these different blueprints that are made of molecules that are DNA, genes, however you want to call them. And that DNA is cut up into different segments known as genes. And those genes can have mutations. I'm sure you've heard of mutations before. Now in the scientific literature, we prefer to call it a variant. Whatever. It's a mutation. It's a variant. Who cares? A variant could also incorporate, however, what's called a single nucleotide polymorphism, which is what we're talking about in this situation. So a single nucleotide polymorphism is a quote-unquote mutation that affects typically only one nucleotide within a gene. So one molecule within a gene, one molecule within the DNA. I'm trying to say it as many different ways so that I make sure that I'm covering my bases and so we're not confused. And with that, that can lead to changes in the expression of particular proteins that are key regulators inside of our cells and allow our cells to do what they need to be doing. So these SNPs, these single nucleotide polymorphisms, what also makes them a bit unique, or maybe not so unique, is that while a mutation is something that happens, is a rare occurrence, a single nucleotide polymorphism is not necessarily rare. It's something that maybe a larger population shares that common change in their DNA. Now, that's not always the case, but it certainly can be. So what they did is they what these researchers did is they screened people's genes. 385,000 people's genes were analyzed for specific known SNPs, single nucleotide polymorphisms, to classify people as either low, moderate, or high risk for cardiovascular disease. Cardiovascular disease would be defined by something like hemorrhage, stroke, heart attack, things like that, peripheral artery disease, anything that's going to be related to your vasculature, to your circulatory system, that's typically attributed to your heart, that would all fall under cardiovascular disease. So if you have some sort of pathology in that regard. But usually the big ones are like stroke and heart attack and things like that. So the researchers, quote unquote, followed these people. It's not like they had hundreds of thousands of researchers or anything that literally followed these people, but they followed them in terms of their statistics, in terms of their doctor's checkups and things like that, over a period of 8.5 years. And they then wanted to associate retrospectively, so after asking these individuals, how well have you been sleeping, or how well do you sleep, or how much do you sleep per week or per day, kind of on average, which of course is going to be self-report, which if you're asking people to try and remember how well they slept even like 3 days ago, that's going to be pretty tough to do. But regardless, it is a method that people use, and probably what would have been better is just using diaries, just telling people, every morning get in the habit of writing down the amount of sleep that you think you got, and then also measuring the quality of sleep. Do you feel really tired after you've slept that night? Things like that. But I don't think that they ended up doing that. They just did. They just looked back at the sleep records that as people were reporting on them after the fact. So they found an association with good sleep pattern and a 35% reduced risk of stroke or heart disease in those higher risk cardiovascular disease individuals. So if you have higher risk of cardiovascular disease based off of that genetic profile, the SNPs that appear, they've grouped you into that higher risk category. If you get good sleep, that reduces your risk of that cardiovascular disease being realized. Now, if I'm frank, I don't actually think that that's probably limited to the higher risk individuals. That's probably true of every single person. I think there's, in a book I was reading, or that I am reading, it's taking me a long time as I'm reading a lot of other books, but one of the books is by Matthew Walker, which I've actually read some of his research, and I've covered it on Physionic before. If you've looked at any of my sleep content, looking at sleep and like food choices, I think that was one of them. Matthew Walker is a prominent sleep researcher, and in that book that he talks about sleep, he mentions that with daylight savings, that when people lose an hour, that there's a strong association with more people dying exactly on that day. So there's this sudden spike in people dying on that day, and then it falls back down, and then you just have normal levels. And then when people gain an hour in the night from the whole daylight savings procedure, I don't really know if it's a spring forward and like fall back, something like that, when it comes to the 1 hour, gaining 1 hour, losing 1 hour, et cetera, et cetera. Well, anyways, when we gained an hour and we could sleep longer, of course, keep that in mind. That's a massive association there. But assuming that you can then sleep longer, that you saw a dramatic drop in the number of people dying from cardiovascular disease, or I think maybe it was just overall mortality. So then that association being then that if you lose an hour of sleep, then you are at a higher risk of having some sort of event. So you're like right on the precipice, right on the edge, and losing that hour of sleep reduces your or increases your possibility of having a cardiovascular event. So that's kind of what these researchers are also saying, but again, this is all associative. So good sleep was considered 7 to 8 hours of sleep, and that led to that 35% reduction in cardiovascular disease risk. Do I buy it? Well, I do buy it based off of other research. I don't really buy it based off of this research necessarily. It's not like I'm sitting here thinking, oh yeah, this is clear evidence that sleep directly affects these genetic profiles and reduces the risk. No, I just think that it's healthier to have a good amount of sleep. We don't sleep for to just boot down for no reason. I mean, sleep has tremendous, and some of the things we haven't even discovered yet, but it has a tremendous effect on our health. So of course, that's going to, if you have the correct amount of sleep, you're going to be healthier. So clearly that's going to affect even people with these single nucleotide polymorphisms. If they had done this in people without these single nucleotide polymorphisms, I'm pretty sure that they would have found at least some reduced level in heart disease risk and cardiovascular disease risk. So not altogether all that incredible of a study, but it's still telling, and it kind of corroborates some of the other research that's out there. So bottom line, get your sleep. Make sure that you get enough sleep and make sure that it's consistent. Okay, so then the next topic that I wanted to discuss is looking at cholesterol. And I'm not going to be blowing your mind here with the cholesterol research. It is very much in line with some of the other cholesterol research, but this study did give some additional information, which I found, kind of interesting, especially since they add another factor into this particular study. So again, this was a study looking at cholesterol and heart disease specifically, and it was an observational predictive study. So they're trying to predict the risk of heart disease. So they looked at 400,000 people at varying ages, I believe, I guess it was, up to the age of, from age 35 to 70 years old. I believe that's right. And they wanted to estimate the risk of cardiovascular events or heart disease at age 75, by age 75. So they looked at data from 400,000 people of varying ages in several countries, specifically in Europe, North America, and Australia. And then they had up to, keyword there being up to, a 43-year follow-up with an average follow-up of 13 years. So taking data points, then 13 years later on average, looking at the data points from there, and then trying to make predictions off of those data points. And they were looking at non-HDL cholesterol. So you may already know this from talking to your doctor, or you may already be educated on this, but your cholesterol, and I was corrected on this once in a video that I made. I'm well aware that that HDL cholesterol is not actual cholesterol. It's a lipoprotein that contains cholesterol, but instead of saying HDL, instead of making that distinction, clinicians often just say the particle name, the actual molecule name of HDL, instead of saying HDL cholesterol, even though they are technically two different things. Cholesterol is one thing, and then you've got esterified or non-esterified cholesterol, and then you have the actual packaging, which is that lipoprotein. So anyways, I digress. So they looked at non-HDL cholesterol, and as I mentioned, you may already know this, that there are different stratifications based on the size of that molecule and kind of the characteristics of the molecule as it's circulating through your bloodstream. And all of that is regulated by your liver, largely by your liver. So you have low-density lipoproteins, you have very low-density lipoproteins, LDL and VLDL respectively. You have IDL, which are intermediate density lipoproteins. It gets that complex. And then you have HDL, so high density lipoproteins. And you have different classifications within those as well, known as different APO classifications, which is something that I still need to educate myself even further on, so I'm not going to be speaking on those, but one day I shall. So anyways, they wanted to look at anything that was not HDL, because HDL cholesterol is, based on the current research up to this point, HDL cholesterol is considered to be a beneficial cholesterol. The idea being that HDL cholesterol takes up cholesterol from the peripheral tissue and brings it back to the liver to be processed. So it's not delivering cholesterol, it's taking up cholesterol. And that's why it's kind of seen as a bit like a janitor, kind of, or a custodian. It just moves around and takes care of everything and then brings it back to its appropriate location to be disposed of. So non-HDL cholesterol is what they were focused on, and that's going to have different levels of risk, but they could just kind of clumped it all together into one. And they showed, and this is the unsurprising aspect, the kind of more interesting aspect, I'll tell you in just a second, the unsurprising finding, which is a good thing, is that they're corroborating this with other research, is that the higher the levels of non-HDL cholesterol, the higher risk of cardiovascular events like stroke, heart attack, things like that, like I was talking about in the last section, and which is going to be carrying over here as well. So cardiovascular risk increases the more non-HDL cholesterol you have. So one of the interesting aspects of this study is that it's also time dependent. So the longer that you have this increased non-HDL cholesterol, then the worse off you are. Now, what's counterintuitive here is that you would think that older individuals would be at a higher risk, but it turns out that is not the case. It is younger individuals. So if they looked at people under the age of 45 with higher cholesterol, they had the highest risk. And you can imagine why, because this is a predictive study. So they're trying to predict where a person is going to be in terms of their cardiovascular health at the age of 75. So you can imagine that if they are younger, if they're like 38 and they have high cholesterol, and then they may have that high cholesterol for up until the age of 75. So there's a longer exposure to high cholesterol in that regard. However, with an older individual, if you're, let's say, 68 years old and you have high cholesterol, maybe you just started having high cholesterol in the last 3 years, and therefore the predictive model is only going to be looking at about 7 years from 68 to 75 years old to predict your risk. So you can imagine that's going to be a time-dependent situation there, and it's going to have quite a serious impact. So if you're younger and you have high cholesterol, that is absolutely incredibly important that you reduce your cholesterol levels to then reduce that predictive marker or predictive outcome. So the actual percentages, they did offer some percentages for the actual predictions, is that if you are under the age of 45 with high non-HDL cholesterol, again, encompassing all of those cholesterol molecules, the packaging, the lipoproteins, your risk was 16% of having cardiovascular event in women and nearly 30% in men. And however, if you are around the age of 60 or older, which I think they only went up to 70, so 60 to 70, that risk was only 12% in women and 21% in men. So then they wanted to take this, so clearly you can tell that it's a decrease there. The older you are and you have higher cholesterol, this predictive equation would reduce your risk. Again, because it can't know what you're going to be. It can't predict what you were before unless you have those data points to actually input into the equation. Then it can actually take that into consideration, and your risk would most likely increase quite substantially. So because this is predictive, what they also wanted to see is, well, if you predict a cutting in half of non-HDL cholesterol, what would happen to that predictive risk? So presumably, if you have high cholesterol, and then you decide, okay, I won't stand for this, I'm going to do something about it, and you are able to reduce your non-HDL cholesterol by half, then, which is a massive drop, then that would lead to a predictive drop, and this is where it's beneficial for the younger individuals, a predictive drop from 16% risk of a cardiovascular event by the age of 75 in women to 4%, so only a quarter of the risk. And in men, from that 29-30% to a drop of 6%, so an even greater drop, an even greater drop in men. However, in the individuals that were over the age of 60 or around the age of 60, they only had about half of a drop. So moving, I believe it was 12% in women. So that would be dropped to 6%. That's still massive. I mean, that's still fantastic. And for men at 21%, that would be something around like 10 or 10.5%, something like that. So it's still certainly highly beneficial based on this predictive equation. Of course, you have to then ask, how accurate this equation is. I certainly didn't look at that. I'm just kind of trusting these experts, these researchers that do research in this area to have done things well. So that is certainly a limitation in what I'm presenting here. Now, there are further limitations on the study itself in that the study had a high degree of Caucasians, so white people, not that racially diverse, not that ethnically diverse, and therefore the translation of this might translate to other ethnicities, but there's also a good chance that it wouldn't, that you may have different results, or maybe you'd have different effect sizes. So the degree of the effect may be increased or decreased with other populations. So that is a limitation of this study. And you can imagine they're looking at Europe, they're looking at North America, and they're looking at Australia. They didn't go to like Africa, for example, or South America, where they would have gotten a more diverse population to investigate. So kind of interesting, adding that time element to it and just making sure that people understand that decreasing your cholesterol risk now, you can say at the age of 28 or 32 or, whatever it might be, you can say, sure, I have high cholesterol, but, I'll take care of that later. No, you definitely don't want to do that because you're doing damage right now. You need to be taking care of that now so that you can decrease your cardiovascular risk events later on. But as an older individual, what you might take away from this is, I've had good cholesterol, for my entire life. I'm 69 years old now. I want to take it easy. I just want to enjoy life and go out retirement and eat my cake and have 3 pieces of cake instead of just having 1 piece of cake. Screw moderation. And if you want to do that, that's fine. I mean, it's fine for anyone, but keep the consequences in mind. However, of course, by this would then predict that your risk would at least be lower than a person who had that mentality at the age of like 31. So kind of cool. Okay, and finally, the last topic that I wanted to discuss is the impact of extremely high sugar intakes on male fertility. So this study wanted to investigate the effect of a weight-maintained healthy diet on, I believe it was like 10 or 16, I don't have it written down, but I believe, something like that, 10 to 16 healthy young male participants, I think around the age of 27, 28. And the researchers wanted to know what the impact of diet would have on male fertility. And their measure for male fertility, which is certainly not all-encompassing, but they looked at a variety of different gene expressions I'm not going to touch on that, but I am going to touch on kind of the functional outcome of the motility of the sperm cells. So a sperm, if they move a lot more, that's a good sign. That's great motility, and that's exactly what you want. That's typically associated with healthy fertility. And so they first stratified the sperm cells of these individuals as either low motility or high motility. And there were two separate groups. So they had the low motility group and the high motility group, but both groups then ended up consuming they first started out consuming a healthy diet. A healthy diet, just vegetables, fruits, just kind of your normal, I guess I don't want to get that confused with a different study. I don't have it written down exactly what, it may have been a Scandinavian diet. Don't quote me on that though. It was something along those lines, but it was just generally a healthy diet as assumed for the most part. I know that's kind of a controversial topic to say that it was a healthy diet. Okay, well, did they eat meat? Because that'll kill you. I mean, I'm joking. I'm assuming that they consumed in moderation a series of foods that would be largely considered healthy. And they did that for just 1 week. And the researchers made sure that it was a weight-maintaining healthy diet, meaning that these individuals did not gain a bunch of weight off of this 1 week of food consumption. And what they found is that there was improved sperm motility in the low motility men with a change to a healthy diet. However, that did not significantly affect the high motility sperm from the men that had the high motility sperm. And that makes some sense. Maybe they were maxed out, maybe they were at maximum motility and therefore could not be improved any further, even with a healthy diet. So there was an effect there, and it was a pretty dramatic effect actually. And then the researchers wanted to know, okay, well then if we keep this same diet, the same healthy diet, weight-maintaining diet up until now, but then we tack on and added 350 grams of sugar every single day, what happens to sperm motility? And they ended up finding some interesting results. You would think that because sugar consumption is going to have a detrimental impact on, just generally increasing blood glucose levels constantly, 350 grams on top of weight-maintaining diet no longer is going to be weight-maintaining. You're going to start seeing increases in body weight, and it was actually, I believe, almost a 50% increase in consumption overall. So it was quite a massive increase in their overall consumption. But with both of those variables included a massive overconsumption plus the overconsumption coming from straight sugar, just like candy, they found that had no impact on decreasing cell motility, so the sperm motility. So the sperm motility had increased up to equal levels for the low motility individuals and the high motility individuals with a healthy diet. And then it did not dip back down to low motility with the addition of sugar. So then I believe the article I read said something about high sugar specifically improves male fertility. You can't really say that. What actually improved it was the healthy diet. But what you can say is that the high sugar for 1 week did not revert or reverse the effects experienced from the healthy diet. So that's really kind of the main point here. And what they think is happening is that the high sugar is leading to a highly anabolic environment, and therefore you're seeing, because these individuals also saw increases in lean mass, which makes some sense, but that's probably only in the short term. We don't actually know if that would persist going forward, and I imagine it probably wouldn't, because they also mentioned some other studies that have looked at obese individuals, so not healthy young individuals, looked at obese men and saw the opposite effect. So with the inclusion of sugar, they saw decreases in sperm motility. So I think overall, it's a safe bet to say that a healthy diet, with the definitions being loose, you'd have to check out the study for yourself. A healthy diet increases sperm motility, great. High amounts of sugar in healthy individuals at weight, normal weights, does not impede sperm motility, at least for a 1 week period. That is probably not going to be the case if you consume 350 grams of sugar above your maintenance calories for 4 weeks, 12 weeks, years into the future, because then you're going to end up in the other condition, which is what I just mentioned. You're going to end up gaining weight, and you're going to end up becoming presumably eventually obese, and therefore then you're going to have a lot of things that could potentially be wrong with cell signaling and endocrine action and things like that, which then would lead those 350 grams to be detrimental, and then you would start seeing those decreases again in sperm motility. So the sperm are feisty buggers, and they will take your gluttony of 350 grams for a week, and then we don't know after that. So kind of interesting. I thought, why not report on that? So if you're trying to conceive, there you go. There's the big takeaway. If you're trying to conceive, change your diet. It makes a difference. That's a big factor. Okay, so that is what I've got for you. Those are the 3 topics that I have for this Physionic podcast. Hopefully you found this informative. Hopefully you found it, you get something out of it that you feel like you can take away something from this information. And as usual, thank you for stopping in. And if you find it useful, feel free to share. That would help me out. And with that said, I wish you a wonderful, wonderful day. And I hope I have the pleasure of speaking with you in the next one. See ya.